Hi, everybody. Welcome back. We are moving on from the limiting reactant homeworks, and we are going to start our last big topic. And good news, I promised, we saved the easiest for last. Percent yield. All percent yield is one extra line in your table. So I'll go flip back. Last thing I have in my notes was homework sheet number 3. Still going to calculate molar mass, limiting reactants, using the reaction and the initial masses. Get the theoretical yield. You're just going to add one more line and calculate a percent yield. So percent yield is, well, I'm not sure if this is a term yet we've used this year. I'm going to guess we've used it. But percent yield is a measure of how successful your reaction is. So it's comparing how much product did you make to how much product should you have made. So like I said, it is a measure of reaction efficiency, I guess, or productivity. The higher your percent yield, the more efficient your reaction. So comparing what should you have made, which is your theoretical yield, to what did you make. Now, percent yield is a really easy calculation. It is simply what did you make, your actual yield, which is usually going to be a number that you get from the lab, to what should you have made, which is your theoretical yield, which is what we've been calculating in the last row of our table, and that's a number you get from the math. So what did you make in lab compared to what did you make in, what did you calculate you should have made? Since it's a percent, take that value and multiply it times 100. So all you're doing now is taking one extra little piece of data, and an actual yield, that's going to have to be given to you. Theoretical yield you can calculate, but percent yield or actual yield will have to give you one of those values in order to complete the calculation. Now, I'm going to start off first with an example, and then I'm going to go back and talk about reasons why actual yield might be different from theoretical yield. Let's see. So example 1, you go into lab and you're going to allow 50 grams of calcium react with 85.6 grams of HCl. I did a lot of HCl reactions to produce 112 grams of CaCl2. So now we've got a third layer in our problem. We know the mass of our reactants, and we know the mass of one of the products that we collected in lab. I want to note, if it says to produce, this is your lab value. This is what you got in lab, which would make it your actual yield. What did you actually get in the real world? Theoretical yield we'll still have to calculate. Now, again, I would set it up the exact same way. We're just adding a layer to our table. We're still going to need to calculate the molar mass. And determine the limiting reactant using a balanced chemical reaction and our initial mass to get our theoretical yield. Compare that to our actual yield and calculate, I lied, it's 2 extra lines, a percent yield. Okay, so big table. Started off our reaction. Calcium is combining with, what did I say, hydrochloric acid to produce, that'll be a calcium salt, CaCl2, and hydrogen gas. Molar mass, calcium is an element, 40.08 grams per mole. I went over in the last video a review of how to calculate this. HCl, molar mass of hydrogen plus chlorine, 36.46 grams per mole. Calcium chloride is 110.98 grams per mole. And hydrogen, 2.02 grams per mole. Balance the chemical reaction. Well, I've got 2 chlorines and 2 hydrogens, so if I throw a 2 out front, everything else is just going to be a 1. Nothing changes. You're still going to fill out the table the same to start off with. So still fill out your initial values. I'm going to start with 50.0 grams of calcium and 85.6 grams of HCl. I'm not going to have an initial mass for the products. Now, I'm going to need a new color. Green. Nope. Okay. Theoretical yield. That's going to look like blue. This time, we are going to have a value here. So, theoretical yield. Whoop, I got to calculate that. Actual yield. That value is already here. My actual yield is going to be 112 grams of that calcium chloride. So that again is coming from the problem. All right, next thing, just like we've been doing, in order to get our theoretical yields, we've got to determine the limiting reactant. So step 1, step A, determine the limiting reactant. Okay, so limiting reactant. We're going to look at calcium and HCl. I'm going to look at calcium first because it comes first. Molar mass, or take your initial, which is 50.0 grams of calcium, grams to moles. 1 mole contains 40.08 grams. 50 divided by 40.08. Let me get my calculator out. I have 1.25 moles of calcium. Take the moles and divide by the coefficient. So that's going to be divided by 1. And my value for calcium is going to be 1.25. Look at my other reactant, which is HCl. I'm beginning with 85.6 grams of HCl. From grams of HCl, I can go to moles of HCl using the molar mass, which is 36.46. And end up with 2.35 moles of HCl. Divide by the coefficient, and I get 1.17. These are close, but HCl is the smaller number, so HCl is going to be my limiting reactant. So I'm going to use HCl in my further calculations. That also means my theoretical yield of HCl is 0 grams because theoretically it's going to be all used up. All right, so after limiting reactant, you could do a couple of different steps. I usually just like to work left to right. So after limiting, I'm going to calculate the mass of the excess calcium. So the mass of the excess reactant. HCl, so I'm using my 85.6 grams of HCl. From grams of HCl, I can go to moles of HCl. Using the molar mass, 1 mole contains 40.08. From moles of one substance, so from moles of HCl, I can go to moles of another. My goal is to get to calcium. And from moles of a substance, I can go to grams of that substance. Mole ratios come from the coefficients, so for every 2 moles of hydrochloric acid consumed, 1 mole of calcium is consumed. Gram to moles come from a molar mass. 1 mole of calcium weighs 50.0 grams. Type it into a calculator, 85.6, divide 40.8, 40.08, divide 2 times 50. My reaction is going to, wait a minute. Let me check that. Oh, that's what I did. Okay. All right. Well, here, I'm going to stop and show you how I caught that error. So I ended up with my reaction is going to use 53 grams. My reaction can't use 53 grams if I only start with 50. So either that meant I did my limiting reactant wrong or I did this calculation wrong. So if you're paying attention, sometimes you will catch the glaring errors. I did catch what I did. 1 mole of calcium, I used the wrong molar mass. Here, I used my starting mass when I should have used my molar mass. That should be 40.08. Okay, let's try that again. 85.6 divide 40.08, divide 2 times 40.08. Okay, that looks better. My reaction is going to use 42.8. Let me see. I got all messed up here. All right, I pulled a lot of wrong numbers. That's a 36.46. Okay, after I get my molar masses wrong, right, third time's the charm. 85.6, divide 36.46, divide 2 times 40.08. There we go. My reaction is going to use 47 grams of calcium used, which means my excess, I can just do that in my head, 50 minus 47 is going to be 3.0 grams of calcium. So that's going to be the mass of my excess reactant. 3.0 grams of calcium. Now I can calculate my theoretical yields for the calcium chloride and the hydrogen. I'm going to start with calcium chloride since it's first. So calcium chloride, using my limiting, hopefully I can get this one looking right. I start with 85.6 grams of HCl. From grams of a substance, I can go to moles of a substance. From moles of one substance, I can go to moles of another. This time I'm going to calcium chloride. And from moles of calcium chloride, I can go to grams of calcium chloride. Now I can go ahead and plug in my numbers. Hopefully I do it right this time. Molar mass of HCl is 36.46 grams per mole. The mole ratio here, those are the coefficients out front. So 2 moles of HCl for every 1 mole of the calcium chloride. And then this very last step is the molar mass of the calcium chloride, which we already calculated. 1 mole is 110.98 grams. Plug all that into a calculator. 85.6 divide 36.46 divide 2 times 110, not 1010. And I end up with a theoretical yield of 130.3 sig figs, so that just rounds to 130 grams of CaCl2. So my theoretical yield of calcium chloride, 130 grams. Next thing I can calculate is my theoretical yield of H2. I'm going to go on a different page. That's fine. I'm still going to fill out that table on the previous page. So I'm still on theoretical yield. This time I'm doing the theoretical yield for H2. Make sure you're using your limiting. So still using that HCl, which was my 85.6 grams. From grams of HCl, I can go to moles of HCl. From moles of one substance, I can go to moles of another. This time I'm going to H2. And from moles of that substance, I can go to grams of that substance using the molar mass bridge. So this one is a value that we know. So HCl, 1 mole, weighs 36.46 grams. Those are coefficients from out front. H2 is 1, HCl is 2. And then that's a molar mass of H2, which is 1, and I think I have to check that. Probably like, do we round that? Yeah, 2.02. Plug all that into a calculator. 85.6 divide 36.46 divide 2 times 2.02. I have a theoretical yield of 2.37 grams of H2. So I can plug that into my table. And this is where we start our new step. So theoretically, this is what I should get. In actuality, this is what I did get. I got 112 grams of the calcium chloride. Actual yield of reactants, not generally going to have that. We don't usually measure how much excess reactant do we have. One, it's usually very hard to measure because you'd have to probably figure out a way to chemically separate it out from the product without destroying the product. Okay, so I've got 3 blanks. Percent yield. For calcium chloride, that one's easy to do because I've got a theoretical and an actual. So I can do the calculation for percent yield. Really easy for the calcium chloride. So for the CaCl2, percent yield is equal to actual over theoretical, so 112 divided by 130. Times 100 if you want to show that step. The percent yield of calcium chloride is equal to 86.2%. So percent yield of calcium chloride would be this line, 82.6%. Now, oops, this line, 82.6%. You might be asked to calculate for hydrogen. The way you would do it if you want to fill in these two blanks. If the percent yield of calcium chloride was 82.6%, the reaction would have had the same efficiency for the hydrogen. So 82.6% for calcium chloride means you would have had 82.6% for the hydrogen. To figure out what mass that would be, it's the same calculation. We're just going to solve for a different area of the equation. This time we know the percent, so we know 86.2%. We don't know the actual yield. We do know the theoretical yield was 2.37. So take your numbers, solve for x, 86.2 times 2.37. You get a gigantic number. That can't be right. Okay, don't do the percent. Let's try the decimal. 0.862 times 2.37. Yep, okay, that looks good. So our actual yield of calcium would be 2.04. So here, do the percent as a decimal. Actual yield would be 2.0 grams of hydrogen gas produced if our equation reacted with the 86.2% efficiency. Okay, last thing in the video. So again, it's just really 2 extra calculations, and one of those numbers has to be given to you. Last thing I want to go over is why. Why is the theoretical not almost ever the same as your actual? So why do we not get perfect chemical reactions? So reasons the actual yield is not equal to the theoretical yield. In general, one of the biggest reasons is reactants don't fully react. So in our last example, we were looking at hydrochloric acid reacting with calcium. Even your limiting reactant, you might not get all of the hydrochloric acid to react. You're going to have some excess reactant, even if it's from the limiting. You also could have different side reactions. So the reactants could react with other chemical substances in the room. A good example of this, and form byproducts or secondary products. A good example of this was your iron sulfide lab. So iron reacts with sulfur to form iron sulfide. Sulfur can also, I'll do a real arrow, react with oxygen in the room to form SO2. So we have intended product and we have byproduct. If you ever get an actual yield that is bigger than your theoretical yield, refer to number 1. You are probably having some procedural, I don't want to say errors, some procedural factors which are throwing off or giving you an incorrect mass for the product in the lab. Some examples of this would be things like solvents, which are usually water. So if your product is wet when you weigh it, it's going to weigh more. Or refer to number 1, you actually are measuring some of the reactants in your product. So just know that if you ever get into a situation where your actual yield is bigger than your theoretical yield, it could be due to some different lab procedures, or it could be that there's still some reactants in your product there.